we were looking at the history of AI and we were trying to see how this idea of knowledge representation has come, the idea of representation essentially, and trying to figure out how we do thinking or how we do reasoning essentially. So, let us look at some more people on the way. So, John Locke, who is also known as the father of classical liberalism, his theory of mind is often cited as the origin of modern concepts of identity and self. I mean, how do people think of themselves, figuring prominently in the work of philosophers as Hume, Rousseau and Kant later. He postulated that the mind was a blank slate. We are born with blank slates, or the tabula rasa as he called it, which is of course different from many other people who believe that we are born with certain innate ideas and concepts and notions. For example, Noam Chomsky, the celebrated linguist, he believes that we are born with a universal grammar essentially, and essentially what you do when you grow up in different societies is that you tune that universal grammar to that particular language. But the notion of a grammar, he says, we are born with. As opposed to that, Locke believes that we are born with an empty slate or tabula rasa mind, and essentially that what we know is determined by experience derived from sense perception. So, as we see the world around us, we create concepts about the world and represent knowledge and so on and so forth. So, Hume was one of the people who also explored this, a Scottish philosophers. Now, notice that we are still way back in time, 1711-76 he was like most people at those times, he dabbled in many things, philosopher, historian, economist and so on. He was a follower of Newton, as we will see, and in his treatise called The Science of Man, he tried to examine what human beings are essentially, the psychological basis of human nature as he said. And his method of science assumes that experience and observation as the foundations of logical argument essentially. So, he was an admirer of Newton. So, Newton of course, we know for the laws of gravity amongst many other things, and he felt that just as Newton could explain physical motion, ideas were also like basic particles to which mental forces and operations applied. So, just as we can say that two bodies which have a certain mass, they exert a gravitational pull on each other, and based on that you can explain why planets are going around the sun and that kind of thing. He says that mental particles, which is what Hobbes had postulated, also obeyed certain laws which determined what is happening with mental particles essentially. Like Newton, he was not interested in how this happened. Newton never questioned as to why is gravitation there. Of course, modern day physicists are still trying to understand gravity, and it seems to be one of the last frontiers of physics. But Newton was not interested in explaining why gravity happens. He just said, okay, if you assume that this is a law of gravitational pull, then you can explain everything. And likewise, Hume said that okay, we can postulate laws of logical reasoning, then we can just accept that it happens because of that essentially. So, he could so he is thinking of thoughts, particles and obeying some laws, but he is not able to associate them with ideas essentially. What makes them ideas essentially, so that the interaction between such particles counts as thinking essentially. So, the notion of meaning he has lost altogether. So, this question of meaning, how does a manipulating agent, how does a thinking agent get meaning out of representations, is a very hard questions in some sense that we are still trying to grapple with essentially. So, Immanuel Kant, we saw he was one of the followers of Locke. So, when he talks, we can hear the first glimpses of things that we now call as ontology. He says that the mind has a priori principles which make things outside conform to those principles. Okay. Now, this is a school of philosophy which says that what we see out there is essentially controlled or determined by what we have in our heads already essentially. And Kant says that we have a priori principles which and what we see from things outside, they conform to those principles. We will see the idea of scripts sometime later in the course as to how we interpret whatever we are seeing or hearing in terms of preconceived notions that we have essentially. So, he goes on to say that the mind shapes and structures experience. So, that on an abstract level all human experience shares certain essential structural features essentially. The concepts of space time are integral to human experience, as are the concepts of cause and effect essentially. We are born with the notion of space and time essentially. Now, this is interesting. He says that we do not have direct experience of the world, what he calls the nominal world, but what we do experience is the phenomenal world as conveyed through our senses essentially. Now, that is a school which has also lot of followers essentially. So, finally, human concepts and categories structure our view of the world and its laws. Concepts and categories are terms that we use predominantly when we talk about ontologies, and we will do that a little bit later in the course essentially. So, the subject object problem, the subject seeing an object, a long standing philosophical issue. So, remember the correspondence theory which Aristotle posed and Wittgenstein accepted the picture theory of memory. We are still addressing the same problem. How can a subject look at an object and make sense of that object? Is concerned with analysis of human experience and arises from the premise that the world consists of objects. It is a premise, remember, which are perceived or otherwise presumed to exist as entities essentially. We will see if we can discuss this a little bit later sometime, but when we see a tree, is the tree, the concept of a tree our creation, or is it really out there essentially? For a tree, it is probably, you might be willing to say that there is a real tree out there, but what happens when you see clouds and things like that? When we see a cloud, are we influenced by our notion of cloud essentially? So, the subject object problem has two primary aspects, and these are modern day terms that we will use. First is the question of what is known. The field of ontology deals with questions concerning what entities exist or can be said to exist. So, the word ontology was used by philosophers essentially. What is this world? What is it made up of? What is an apple? What is a cow? What is a cheetah? So, concepts essentially. And how such entities can be grouped, related within a hierarchy and subdivided according to similarities and differences. This is what we will do when we construct a taxonomy of some kind essentially. The second standpoint is how does one know what one knows. So, the epistemological problem is how is knowledge acquired and what do we know essentially. I mean, it is in some sense it is talking about facts essentially. Ontology is talking about concepts as to what are the kind of concepts we have. I have a concept of a chair, I have a concept of a light, whereas this is a particular light and that is a particular chair, that is epistemology essentially. So, knowledge based systems can also be called as epistemological systems. And the bounds of our own minds essentially. So, this is Kant, we are still talking about this thing. He claimed to have created a Copernican revolution in philosophy. Copernicus created a revolution by telling us that what you see is not what really out there. You see the sun going around our earth, rising and then setting, but it is really the earth which is rotating essentially. And the similar notion was coming with the notion of the mind essentially. So, if you see what you see in your mind is not really necessarily what is out there essentially, but we are bound by our minds and the moral philosophy of autonomy of practical reason, in the sense that we are constrained by our reasoning abilities. I will skip some of this stuff but highlight the stuff in blue. He is talking about mind's processes, the product of rule based activity. So, our interest is in not only in representation, but in reasoning. How can we operate upon those representations to come up with new things, new ideas or new conclusions and so on. And Kant is also talking about the mind's process, that the mind has processes which works on those representations, which some he has called as rule based activity. For us, rule based activity will be a more precise term, which we will see. Just a quick recap of how AI got its name. It is credited to John McCarthy and Marvin Minsky and Claude Shannon. Principally McCarthy was the one who was supposed to have suggested it. They organized this conference called the Dartmouth conference in 1956, which was to be a 2 months 10-man study of AI on the basis of the conjecture that every aspect of learning or any other feature of intelligence can in principle be so precisely described that a machine can be made to simulate essentially. So, this is the sentence where the term artificial intelligence was used first essentially by McCarthy essentially, and you can find this description of this history of the Dartmouth conference in a full chapter in this book called Machines Who Think by Pamela McCorduck essentially. So, these are the organizers: McCarthy, Minsky, Rochester, an IBM engineer, Claude Shannon, we all know as who gave us the concept of information theory. We will look at some work by McCarthy and Minsky much later in the course, when we looked at the notion of default reasoning or something called circumscription, which is due to McCarthy, and Minsky we will look at the idea of structured knowledge as to how we group together things which eventually led to this thing called object oriented programming essentially. But the show stealers in the Dartmouth conference were two relatively unknown people, Herbert Simon and Alan Newell, who apparently, according to McCorduck at least, almost as an afterthought essentially, but they were the ones who really created the biggest impact, along with J.C. Shaw, also from the Rand Corporation. All this is now part of CMU or Carnegie Mellon University. They built a program called a logic theorist. Now, we will look at such programs to start with. It was the first program deliberately engineered to mimic problem solving skills of a human being, and by this we mean logical reasoning, the kind of syllogism that we saw. Given some premises, what else can you conclude? Can a program do it for you? So, that was the program logic theorist, one of the earliest theorem provers. We will spend some time looking at theorem proving in this course, but in the 50s and 60s, when the Dartmouth conference was going, they already were demonstrating this logic theorist essentially. It went on to prove several theorems in Russell and Whitehead's celebrated Principia Mathematica, finding shorter and more elegant proofs for some essentially. So, some comment about creativity you might say essentially. So, these are the two characters, Simon and Newell. Herbert Simon is probably the only Nobel Prize winning computer scientist, but he got a Nobel Prize for economics, not for computer science, because we do not have a Nobel Prize in computer science essentially. And his student Newell essentially, both of them set up a big school in Carnegie Mellon University, which was very influential. So, they became leading figures in the AI research at CMU. They wrote a program called General Problem Solver, which basically characterized heuristic search and some problem solving strategies like mean sense analysis. But more importantly, they provided the information processing approach to AI, or whatever you call as classical AI nowadays. One shining example at CMU was a program called SOAR, which we will look at a little bit later in this course, and maybe you will have to write some programs. It is a programming system or a cognitive modeling system, which we will use to write some programs, developed by John Laird, I think. Now, this is one of the bases for what we want to do, is the physical symbol system hypothesis given by Simon and Newell. So, when you are talking about representation now, a symbol is a perceptible something that stands for something else essentially. Alphabet symbols, numerals, road signs, musical notation, all these are symbols. If I write a squiggle on a blackboard, then you perceive it as a number 7, for example. Now, it is a squiggle which is a symbol which is standing for the number 7. So, somehow we managed to represent the notion of number 7 by some strokes of chalk or pen that we are talking about. A symbol system is a collection of symbols. It could be a pattern, words, arrays, lists, or even a tune. And a physical symbol system is something, a symbol system which obeys laws of certain kinds. So, remember the kind of stuff that Hume is talking about, that you manipulate symbols using certain rules, just like gravity controls physical motion, some rules will control the manipulation of symbol systems essentially. So, algorithms, we are familiar with algorithms. So, we will also use the term algorithms, long divisions for example. So, the physical symbol system hypothesis, it is a hypothesis, I mean you cannot talk of it as a law or something. What Simon and Newell say is that a physical symbol system is necessary and sufficient to produce intelligent behavior, which is of course different from what some people call a strong AI, which says that you have to have a certain kind of architecture, you have to have a certain kind of hardware for AI or for machines to be able to think. What Newell and Simon are saying, nothing, it is the ability to represent something and to manipulate those representations is enough to create intelligent systems, and that is known as a physical symbol system hypothesis, and the whole of classical AI is built on that basis. Hogiland calls it good old fashioned artificial intelligence, which is as I said in contrast to strong AI and other approaches to interesting stuff I should say, or intelligence, statistical approaches or neural networks, which are in neural networks you do not have a representation, you do not know how you represent something. Somehow there is a complex network of neurons and connections between neurons, and the weights that we attach with those connections somehow capture the concepts that we are trying to capture. So, of course, we can learn or train a system to know what is A, what is B, what is C, you can do character recognition, but we do not know how the system is representing. Whereas, in classical AI we have our very clear explicit representations which we work with. Okay. So, since we are talking about agents representing the world around them, let us ask some basic questions. So, what is really out there and what do you mean by objective reality essentially? Now, if you look at it very from the fundamental point of view, one thing is clear that everything in the physical world is made up of some number of fundamental particles, and we may dispute, we may debate about what are the fundamental particles, but let us assume for the time being that we accept something like an atom to be fundamental. Of course, we know that atom is not a fundamental particle, it is made up of proton, neurons and electrons, and they in turn are made up of still smaller particles, but let us not worry about that. But at some level we assume that there are some fundamental particles, unless we believe in something called idealism, in which we say that everything is the world of ideas and matter is only a manifestation of ideas, but let us not get into those philosophical things. Let us assume that the world is made up of fundamental particles, and once we have fundamental particles, the laws of physics are enough to explain the behavior of these particles. So, in principle at least you can understand the world in terms of the particles that anything is made up of and apply the laws of physics essentially. But of course, in practice, as you can guess, that is not a good idea. For example, if you are talking about a human being, then we are typically made up of about 10 raised to 27 atoms, which is a number that you should try to think about. It is not something that you can imagine quite easily essentially. Just think about it in terms of let us say in terms of time, how much is 10 raised to 27 seconds essentially. Now, these 10 raised to 27 objects, which mean people like you and me, interact with zillions of surrounding atoms. So, we breathe the air, we eat food, vibrations from air molecules, sound waves and so on and so forth essentially. Can we ever hope to understand the world in terms of these fundamental particles, and can we write down equations and solve them? Even if we could these millions of equations and solve them, what will we get out of this? We will only get a prediction of their location and movement, whereas what we want to know is some high level, what many people have called as epiphenomena essentially, that if you throw a ball at somebody, then somebody will stretch out with his hand or her hand and try to catch it. Now, this kind of reasoning you can't even imagine doing it with fundamental particles. So, the world may be made up of anything, but we as human beings are forced to think of it in our terms. So, this is the idea of Kant, that we have ideas in our head and we see the world in those ideas. Now, it is a necessity, because obviously we cannot reason with 10 raised to 27 particles essentially. So, we create the notion of concepts, we create the notion of people, chairs, lights, apple, banana and everything, and we reason at that level of representation. So, the worlds are in our minds, the worlds that we think about are in our minds, in principle we can explain the world with physics. So, I can try to predict that this, let us say this fielder on the cricket field is going to try to catch the ball by applying laws of physics, but you can imagine how mind boggling that exercise would be. We tend to think at different levels essentially. We create our own worlds in our minds, and these are the representations that we are talking about, even as human beings essentially. Okay. So, we are not necessarily talking about machines. These are the kind of ideas which are exploited in movies like The Matrix, for example, or Inception, where what is going on in your mind is not necessarily in direct correspondence with what is out there in the world. So, we cannot reason at that level, we cannot use physics to understand the world, we have to create our own scheme of things, and what Newell and Simon have said is that the physical symbol system hypothesis is enough essentially. So, this is what I have been talking about for intelligent agents. What is an intelligent agent? An intelligent agent is something. So, if you see this diagram, you see a face essentially. So, that is the face of the agent, and inside the face or inside the agent's head, you might say, is a model of its world, which is that grey circle that you see essentially in it. So, an intelligent agent has to create some sort of a model of the surroundings of the world it is operating in its head, and a self aware agent, because many people have argued that self awareness is critical to intelligence essentially, that humans are intelligent because we are self aware, we have consciousness and these kind of things. But we can sort of just say that self aware agents will have a model of themselves inside the model of the world that they have. So, that oval, that grey oval that you see is a model of the world that the agent has. It may not be a perfect model, because we can never represent the world perfectly. It may be some approximation, and that is the problem, that is true of all kinds of modeling activities. You always approximate out certain features, and in that model if you create a model of yourself, then you are self aware essentially. So, when we talk of intelligent agents, we talk of persistent autonomous proactive goal directed entities. We can think of them as programs or people. So, when we do information processing, of course, when we interact with the world, when you are looking at me or when you are hearing what I am saying, we are not doing it at a symbolic level. I mean, what you get is eyes impinging up into your rays impinging into your eyes, and somehow you make sense of that. What we get is in some sense analog signals essentially. The sound that we hear are basically vibrations and so on and so forth. So, there is a layer, this is my model of how thinking happens. There is a layer of signal processing on the left hand side when we sense the world. Then there are certain neuro-fuzzy systems which can convert signals into symbols. So, for example, a neural network can take an pixel array and convert it into a character A, can say this is character A, this is character B and so on. So, it can convert signal into a symbol, and what we are concerned with in classical AI is symbolic reasoning, which is the inner core of reasoning. Then we can do some decision making and do actions, which is on the right hand side. So, there may be things like motor control, you move your arm if you want to throw a ball and so on and so forth. So, AI has many topics which are listed here, including everything in some broad sense falls into AI. Even if you talk about neural networks or pattern recognition or image processing or speech recognition or graphics or robot control. But the dotted circle kind of represents more of classical AI, the symbolic AI that I am talking about, and within that also there are many things. So, for example, qualitative reasoning, machine learning, memory, planning, adversarial reasoning or game playing. We will be focusing on what is in blue here, which is predominantly knowledge representation, logic, ontology, semantics, certain amount of search for reasoning, handling uncertainty and a little bit of natural language understanding. So, let us just give a few definitions to these terms. So, what do we understand by the word knowledge is basically whatever you know. Humans deal with knowledge of many kinds. We have models of the world we live in, we have models of ourselves in the world, we have knowledge of society, knowledge of facts, knowledge of how to do things, what is correct in one situation, what is not correct. All this is knowledge which we have to deal with essentially. Ontology we have already mentioned is knowledge about how the world is conceptualized or what are the conceptual categories in the world essentially. So, there are apples, there are goats and so on and so forth, that is part of the study of ontology of concepts and the relations between them. Epistemology is knowledge about what is true in this world essentially. A knowledge based system typically refers to systems that employ domain specific problem solving knowledge in some form or the other essentially. And a word about memory. So, we are not going to be very much concerned with memory here, but it is our repository of knowledge. The knowledge that we have sits in our memory essentially, and in human beings memory is dynamic essentially. We keep continuously learn and update our memories and so on and so forth essentially. So, just let us repeat what we talked about representation. Let me just throw in another word called semiotics. Semiotics is a science of symbols essentially, and according to semiotics a symbol, and we have already mentioned this when we talked about the physical symbol system hypothesis. So, a symbol is something that stands for something else essentially, and we have said number 7 can be represented in many different ways, and these are different symbols for a concept whatever the number 7 means to you. So, you just try to think about what does the number mean to you essentially. I mean, what is 7? I mean, apart from the representation that we are so familiar with. Road signs that we see all the time, curves, pedestrians, schools, they tell you there is a school here, the pedestrian crossing here, or there is a U-turn you can take here, or there are eating place coming up. These kind of are signs essentially. All languages that we work with are semiotic systems. They are made up of symbols, including the languages like English and Tamil and Hindi, or formal languages or programming languages like C++ and Java. All are semiotic systems in which symbols stand for something else essentially. So, it is just a collection of symbols which stand for something else. There is also a term called biosemiotics, in which how complex behavior emerges when simple systems interact through science essentially. So, there are very many examples about how bees interact with each other, how ant colonies, how ants in ant colonies leave small messages for each other and that kind of thing. So, all these are semiotic systems, they communicate through science essentially. So, here is a nice picture I took from this book called Conceptual Structures by John Sower, and essentially to ask the question which many people ask, why don't you use natural language English or Hindi for representation essentially. The reason is, as you can guess, that richness of the language, ambiguity of the language, verbosity of the language, impreciseness of the language essentially, which is why if you happen to read any legal document where they try to be really precise, you can see that most of us can't make any sense of any legal document because it is so verbose essentially. So, it is not, it is a good medium for communication, but here of course, the diagram is saying that that is also not always very successful. So, this is a poor policeman trying to give directions to someone. There are people of course who say Sanskrit is the language of computers, but we will not get into that. I mean, the only thing you can say about Sanskrit at this moment is that it has very well defined rules. It's mostly unambiguous, I think, largely unambiguous.